Let x1, x2, and so on xn be a random sample from the double exponential distribution having PDF f of 1 by 2 f of x comma theta is 1 by 2 into e to the power of minus of x minus theta. So that means if we consider the likelihood is product of I is equals to 1 to n half into e to the power minus of xi minus theta, which is 2 to the power of minus n into exponent of minus summation I is equals to 1 to n mod of xi minus theta. So that means the likelihood function depends on the sample only through the values of mod of xi minus theta. So that means the minimal sufficient statistic for theta is nothing but the entire unordered sample x1, x2 and so on xn, because there is no one-dimensional sufficient statistic for this location parameter theta, as like we used to have in the other distributions like normal distribution and all. So that means we can clearly see like option 1 is the correct answer. Now the second statement says the sample median is unbiased for theta. So we know that the sample median is nothing but MLE in this case for Laplace distribution. So and this is also consistent. So this is like the sample median is MLE and it is also consistent, but the sample median is not an unbiased estimator of theta in case of Laplace distribution. So therefore statement 2 is correct. Statement 3 says xn is the sample maximum is not sufficient as well as MLE for theta. We know that the MLE is, we have just seen like it is sample median. So x of n is not sufficient as well, and it is not even MLE. So therefore statement C is incorrect. Now statement 4 says sample mean is MLE and consistent for theta. Now first of all, like MLE for theta is sample median, not the mean. So and the mean is consistent for the center but not for the MLE. So therefore statement 4 is also wrong. So statement A is the correct answer.